Hello everyone. In this video, I will introduce you how to use simulation software in Principles of Electric Circuit course. There are a lot of free simulation softwares you can download and use them. If you are using the Windows platform, we have two recommendations. One is NI, a simulation software company, collaborated with Analog Devices, a hardware company, created a software called Multisim Component Evaluator. I put its download link on the screen. Another is Tina, a simulation software company, and TI, a hardware company. They launched a simulation platform, Tina TI. I also put the download link on the screen. However, if you are using Mac or Linux, you also have lots of options. The download link of these softwares are on the screen. In the course of this semester, we will focus on Multisim to introduce the simulation softwares. We will show you how they play an important role in the circuit analysis. Okay, this is a window of Multisim, the same as most majority of Windows softwares. It has a menu bar and common shortcut buttons. The difference is that it has a lot of shortcut buttons for component placement and shortcut buttons for the instruments placement. And here is the switch. We give an example now, tell you how to draw a circuit and simulate it in Multisim. The circuit consists of two voltage sources and two resistors. We start by placing the elements. Click here and open it. This is a place for power supplies. We select DC power supply, click OK, put it here. Its default value is 12 volts. We put another. Of course, every circuit needs a ground or a reference point. We choose one and put it here. In addition to the two power supplies, we need to place two resistors. Select Basic and select Resistor. Lots of resistance values are for your selection. We choose the default value that is 1k ohms. Then choose another one. Now all elements have been placed. We turn off the window. Next, let's connect the elements. Connecting line in Multisim is visualized relatively. Move mouse to a terminal and left click, then move to another terminal and left click. It will form a line automatically. Analogously, connect all elements one by one. If you think the default connections are not elegant, you can drag it to the proper position. You can also drag the components. Drawing is completed when all components are connected. In the subsequent lectures, we often need to know the serial number of each node. We also want to know the reference direction of the default current flowing through each element in the simulation of Multisim. That is from where to where. So in the interface, we need to make some changes. Right-click and choose Properties. Then the net names, choose Show All. Choose Footprint in Pin Names and click OK. You can see all points connected with ground are 0 nodes, all reference points. Other nodes have serial numbers such as 1, 2, 3. For all these serial numbers, we will use them later and they are very important. For each two terminal elements, there are two terminals with 1 and 2 respectively. Each terminal 1 has 1. It means that the default current calculated in Multisim flows from terminal 1 to terminal 2. Next, we move on to the simulation. There are two types of simulation in Multisim. The first type is to simulate by the menu. We start the Simulate analysis from the menu. This is a DC circuit. We conduct the simulation of the working point for DC. It gives the values of all branches. We are interested in the current of R1 and the voltage of node 2 and the power absorbed by R1 and. Now we click Simulate. We can see the results. The results show that IR1 equals 6 picoampere. It is reasonable because the potential of the left and the right are all 12 volts, so the whole circuit has no current. 6 picoampere means it hardly has any current. PR1 is 0. this is also reasonable. The voltage of node 2 is 12 volts. It's also reasonable. Because the entire circuit has no current, so here are all 12 volts. It confirms our initial hypothesis. This is the first type of analysis. Another is to use a measuring instrument on the right side. Today we'll use two of them, that is a multimeter and a current probe. We'll place them respectively. Start with the multimeter. Open multimeter, and it has a lot of options. You can measure the current, the voltage, the resistance, and the dB values. Under the situation of AC and DC, today we will focus on the voltage and the current for DC. Let's measure the voltage across R1. You need to move positive to here and negative to here. It means that the first multimeter measures the voltage drop from left terminal of R1 to the right one. We place the second multimeter to measure the current of the whole circuit. We need to break this line, connect it with the power. That is to say, the multimeter is connected into the circuit in series. Open it and choose the current. Then we place another multimeter here. Click this terminal with a positive polarity and connect this terminal with the ground. We introduce the current probe here. Look at the arrow. It measures the current flows to the right. Each milliampere at this point, it shows 1 volt relative to the ground. We change this setting into 1 millivolts to each milliampere, corresponding to 1 volt per 1 ampere. We open it and measure the voltage. We need to know that it's measuring the voltage, but its actual value is the current of the same direction. We run it by click the button Start in the upper right corner. OK, we get this number. We stop the simulation and analyze it. The multimeter 1 shows 6 nanovolts. It's close to 0. That's reasonable. It's almost no voltage because of no current. The multimeter 2 shows 0. It has no current. The multimeter 3 shows minus 18 picovolts. The value corresponding directly to the current here is minus 18 picoamperes. It's also reasonable. Results of this simulation are consistent with our previous simulation data through the menu. Now I have a question to anyone: why the value measured by multimeter 3 and multimeter 2 are different? Think carefully. We remove these multimeters and back to the original circuit. We should recover the circuit connection before conduct other simulations. Then let's do another simulation. Sometimes we want to know that when a parameter of the circuit is changing, how other parameters in the circuit changed accordingly. We now know R1 is 0 when the voltage V1 is 12 volts, but we are interested in the change of R1 when V1 changes from 0 volt to 22 volts. Multisim can provide a convenient function for this purpose. It is a parameter sweep. We choose Simulate Analysis Parameter Sweep. Let's take a look at these settings. We want to change the power source, the current value of DC. V1 is 12 volts. We change it to start from 0 volts and stop at 22 volts. For every 2 volts, we need a simulation point. That is, a total of 13 points are sampled. We do DC analysis. For the output, we want to see the change of curve of R1 with the change of V1. It is a straight line in Multisim. We can draw a grid. Also can get its value by adding cursors. There are 2 cursors. Let's drag the second cursor first. It can be seen that as I drag the cursor to the right, the group of values are changing. The x is the value of V1, the y is the value of IR1. We can see the value when dragged to this location. The current is 6 microampere when the voltage is about 12 volts. It's generally consistent with the value of the simulation. That is 0 ampere when 12 volts. Then when we drag it to the right end, about 24 volts, the current is 6 milliampere. Is it right? 24 minus 12, then divided by 2K, 6 milliampere is right. We look at the cursor 1 on the left. It is minus 6 milliampere when 0 volt. Is it right? 12 minus 1 then divided by 2K equals 6 milliampere. It's minus 6 milliampere due to the left direction. It is right. Okay, about the simulation, that's it for today.